Guys, I hope this finds so great. I'd like to welcome each and every one of us to my channel of Earnest Sciences and Mathematics TV channel. In my preview today, I'm going to look at what we're going to expect under the concept of radioactivity. And this is going to be a very important topic which we're going to come across in our various studies, especially under the topics in chemistry and physics. And also, we're going to be borrowing extensively from various topics which we have learned, especially in mathematics, in trying to do analysis of various aspect of this radioactive phenomenon. Now, in a sense, by definition, this specific concept of radioactivity refers to the spontaneous disintegration of non-stable atomic nuclei and nuclides, and this is going to be released by, of course, followed by a release of energy and, of course, a formation of new particles, which we're going to be seeing, especially in some of our videos, which we're going to be discussing. And of course, we're going to be studying this specific phenomenon and try to see how it's going to be relevant for us and appreciate some of its applications in our day-to-day lives. Now, in a sense, we're going to see that from this specific development of the concept of an atom from the time of Democritus, there are subsequent works which have been done to try and describe the concept of an atom. And in a sense, in understanding the whole structure of an atom from the previous, of course, from the time of its discovery or, of course, inception of this idea to the present understanding, it's going to assist us on how this specific, of course, process of radioactivity occurs. Now, in a sense, we're going to see that this is going to be inferring to the concept of stability of various atoms. And from a specific study on the structure and the composition of an atom, we said that an atom is made up of subatomic particles, which of course include the electrons, neutrons, and protons. Now, in a sense, we're going to see that these specific atoms are going to, or various elements are going to be either stable or unstable. And this stability is due to the composition of the various subatomic particles, which we have said. Now, in our previous discussion, we said that there are various other scientists who had come up with basic ideas on how we can describe the structure of an atom. And this include the, of course, the description which was done by Sir Joseph John Thomson, and this gave us the plum pudding model. Now, the subsequent advancement gave us a present understanding of the atom due to the input of various scientists, whereby we had, of course, looked at to an extent of trying to understand the concept of the quantum mechanical model, which was, of course, proposed by Niels Bohr and other, of course, scientists like the concept of Louis de Broglie through the de Broglie's hypothesis, which gave us the wave-particle duality. Now, in a sense, we're going to consider this one as some of the, of course, inputs which are going to assist us in understanding the whole aspect of the atomic structure. Now, away from that, we're going to see that the specific composition of the atom in terms of its nucleus is going to be consisting of what we refer to as the nucleons. And these nucleons are going to be consisting of the protons and the neutrons that are consisted in the what we refer to as the nucleus. Now, the works of Ernest Rutherford in trying to perform some of the experimental interpretation of this alpha bombardment of an element is going to be giving a clue on what the nucleus consists of. And these are going to be the protons and the neutrons. Now, in a sense, we're going to see that this specific bombardment gave a sense in which there's going to be some kind of intense scattering of some of the alpha particles. And as we are going to see, the alpha particles are going to be positively charged particles. Now, in a sense, we expect this deflection by, of course, the specific elements are to be caused by an intense electrical field, which basically is going to be caused by a positively charged center, which is going to be, of course, scattering this specific particle. Now, from the basic law of attraction, then therefore we are going to conclude that there are going to be positive charges at the center of an atom, and these are going to be, of course, consisting of what we refer to as the protons. Now, in a sense, Ernest Rutherford's work together with the subsequent input of the other scientists who had suggested on the basic structure of an atom are going to be giving us a clue on how these specific, of course, protons, neutrons, and electrons are going to be arranged. And this is going to be giving us a basis of how basically the concept of radioactivity occurs. Now, in a sense, we're going to see that in the nucleus, there are going to be protons and the neutrons, which are going to be there, which are positively charged and neutral. Now, this is going to be consisting of compacted, of course, forms of particles which are going to be existing in a nucleus. Now we can picture a case whereby there are positively charged particles which are compacted together, and from the basic laws of attraction, we expected that there's going to be some repulsive forces. Now, in a sense then we are going to conclude that there are some short-range and strong forces which are existing in the nucleus, and we expect some sense of instability to be existing in this specific nucleus due to imbalance of some of these kind of course, forces which we have said. Now, but we're going to see that from studies, we're going to see that there's a specific trend of whereby the ratio between the protons and the neutrons are going to be exhibiting some sense of stability, whereby the even number of a neutron to proton ratio is going to be showing more stability over the nucleus as compared to the odd number. Now, in a sense, this is going to be the case whereby we're going to see that the concept of a pairing of the like neutrons over the protons or neutrons are going to be giving this specific kind of a pairing, whereby the even pairing is going to be giving us more stability than the uneven pairing. Now, for unstable nucleus, nucleus Now, in a sense, this is going to be referring to the concept of radioactivity, which basically is the spontaneous disintegration of an unstable atomic nucleus to form stable nuclides. And of course, this process is accompanied by a release of energy and formation of new particles. Now, in a sense, these specific atoms which are going to be undergoing this, or nuclides which are going to be undergoing these specific processes, are referred to as radioisotopes. And the process which is going to be involved is going to be referred to as the process of radioactivity. Now, there are various other processes which we are going to be studying in this specific videos that are going to be, of course, shared. And this includes the concept of alpha decay, the beta, of course, decay, or the beta decay kind of process. And we shall look at the alpha, of course, the gamma emission, and of course, positron emission, negatron emission, and the concept of electron capture, of course, the concept of internal conversion, etc. We shall also look at various areas of the concept of a mass defect, and of other aspects which are going to constitute the empirical equation, which is going to assist us, of course, try to quantify some of the aspects which we are going to come across. Now, there are various other processes which we are going to be looking at, especially the concept of nuclear fission, and this is going to be assisting us try to, of course, understand how other processes which are going to be involving, of course, nuclides with atomic mass of greater than 200 are going to be involved. And this is going to be, of course, further complementing on this specific concept of radioactivity. Now, the tail end of these specific discussions, we're going to look at various applications of the concept of radioactivity. And these are going to involve various application areas of medical field in terms of diagnostic procedures and trying to monitor some of the rates of reactions and chemical reactions. And of course, acting as tracers and trying to, of course, monitor some of the uptake of drugs either in plants or animals. Now, in a sense, we're also going to be seeing that this is going to be involved in trying to come up with the concept of energy, especially in the concept of a nuclear fission, which is going to be, of course, used in trying to produce or in trying in production of electricity in nuclear reactors. Now, there are some of the adverse effects which are going to be associated with this aspect of radioactivity. And in a sense, we're going to see that Marie Curie is one of the earlier, of course, members of this specific research scientist who came, of course, who had an effect from this specific exposure to the concept of these radioactive isotopes. Now, in a sense, this is going to be assisting us understand the whole aspect and try to have a way in which we can, of course, try to analyze a few or other aspects which we're going to come across under the concept of radioactivity. I'd like to encourage our members to be checking our description boxes of various links which we are going to share, and also try to, of course, engage us in the various platforms which we are going to be, of course, involved in, and of course, try to share with the friends so that we can form a large community of members discussing these specific topics. Now, I'd like to wish the best of us in our endeavors, in our everyday lives out there, and of course, try to join us in our next discussion, whereby we're going to be looking at different topics in math and sciences. So that is it for now, guys. By God, please. We'll catch us in our next video.